Welcome. All right, so what I'm going to do for this problem is I'm going to use f of w, which is a little odd, but we'll have a little fun in it. So first thing I want to determine is the end behavior. So I look at the degree and I notice that the degree is even, and since the leading coefficient is 4 as well, but this one is positive, I know that when I have an even degree and a positive leading coefficient, my end behavior is to rise left, rise right, and that's it. Now the next thing, which is a little bit more detailed, is now going to be finding the zeros. So to find the zeros, I need to set my output equal to 0. And then I need to determine how am I going to find the values of w that make this true. And I see that I have w to the 4th, w squared. I'm just like, oh man, this is going to be tricky, right? I know that I'm going to have to factor. And I look, it's a trinomial, which is helpful because we've done a lot of techniques with factoring trinomials. But they all don't have a w. So I'm going to have to factor with w to the 4th and w squared, which is OK. However, I do notice that they all factor out a 4, which is good. So 0 equals 4. So I can factor out a 4, I'm sorry. So that will leave me with w to the 4th plus 10 w squared plus 11. Now, I can factor this further, right? If I was to factor this further, I could say what two values multiply to give me 11, but add to give me 10? Well, we know that those two values, I messed up somewhere. That's minus 44. Sorry about that. OK, so now what I need to do is determine how am I going to now change this answer, or how am I going to determine what two values multiply give me negative 11, but add to give me then a positive 10. So 0 equals 4 times w to the 4th, w squared times w squared. Now, why am I writing w squared? Well, remember, I have to get w to the 4th. And when factoring this down to two products, they have to multiply to give me my trinomial. Well, w times w is not going to give me w to the 4th. It has to be w squared times w squared. And then what two numbers multiply to give me negative 11, but then add to give me a positive 10? Well, that's going to be a positive 11 and negative 1. Now I can apply zero product property. Now we got to get a little careful here when we're looking at zero product property. I'm not going to write 4 equals 0. Remember, we're trying to find the values of w that make this true. Well, if I set 0 equal to 4, we know that's not true. So that's not going to give us a value. So what I'd like to do is divide the 4 out. So therefore, I'm left with 0 equals w squared plus 11 times w squared minus 1. Now I can apply the zero product property with these two zeros. All right, so now by solving for my w, I subtract the 11, and I have w squared equals negative 11. Well, we know to solve for w, I have to take the square root of both sides, and we can't take the square root of a negative number. That would produce us with imaginary, which we'll talk about a little bit later. So therefore, these zeros are not real. They do not exist in the real plane. However, if you are kind of interested in what they would be, it's plus or minus the square root of 11i. But they're I as imaginary, not real. So we're not going to go through this. We'll do that later. Here, though, I add the 1 to both sides. And I get w squared equals a positive 1. Take the square root of both sides. W equals plus or minus 1. Remember, when producing the square root, we have to make sure we take the positive and the negative value of our root. We notice that these two roots, we go back to the factor, we notice the degree on our factor is 1, even though I know, yes, it says w squared inside the factor, but the factor has a degree of 1. Therefore, these two zeros have a multiplicity of 1, and these two zeros are imaginary and do not exist on the real plane. So there you go, ladies and gentlemen. That's how you factor solve, determine end behavior, all the above.